You think you understand time. You wear a watch. You feel yourself getting older. You remember yesterday, and you plan for tomorrow. Time seems obvious, as natural as breathing, as reliable as gravity. But that's not time. That's a sensation, a biological trick your brain plays on you to keep you alive long enough to reproduce. Most people walk around with this poetic idea in their heads that time is a river. They imagine it flows, sweeping them along from the past, through the present, and into the future. They think it moves. But here's the problem with that beautiful image. If time is a river, how fast does the river flow? 1 second per second. That's meaningless. That's like saying a table is 1 table long. It tells you absolutely nothing about the nature of reality. The truth is much stranger, much more mechanical, and honestly, a lot less romantic than a flowing stream. Time doesn't flow. Time doesn't push you anywhere. And if you think you have a good grip on how time works just because you can count seconds in your head, you're about to discover something that will fundamentally restructure how you perceive every moment of your existence. This is where most people check out. They want the comfortable version of reality. They want the river metaphor because it feels right, because it matches the story their brain has been telling them since childhood. But if you're still here, if something in you recognizes that comfort isn't the same as truth, then what comes next will change everything. You'll never look at a clock the same way again. You'll never experience a moment without knowing what's really happening beneath the surface. Let's start with what goes on inside your brain, because that's where the confusion begins. You think your internal clock is a reliable instrument. It isn't. It's a chaotic mess of translation schemes that barely hold together. Consider a simple experiment that Richard Feynman himself loved to demonstrate. Try to count to 60 seconds in your head. Just sit there and count 1, 2, 3. You think you're tracking time, but what you're really doing is running a very specific, very personal program that has almost nothing to do with the actual structure of the universe. Some of you, when you count, hear a voice in your head. You're literally speaking to yourself, sub-vocalizing each number in sequence. If someone interrupts you and asks you to speak, you lose your count immediately. The machine jams because it can only run one verbal program at a time. But others, and this is where it gets genuinely strange, don't hear a voice at all. They see images. They might see a tape measure with numbers clicking past, like a ticker tape, a visual representation of duration that operates on completely different neural circuitry. If you use that visual tape measure system, you can actually read a newspaper while you count time. You can sort your socks, examine patterns in the weaving, and still keep that mental tape measure clicking along perfectly. But the person who counts with a voice cannot read a single word without losing track of time completely. This tells us something fundamental about the nature of human perception. What you experience as the passage of time is just a mental construct, a pattern-matching game your brain plays using whatever cognitive resources it has available. It varies wildly from person to person. It is not a universal constant. It's a biological hallucination that evolved because tracking duration helped your ancestors avoid predators and find food. So when we talk about physics, when we talk about the universe, we have to throw your brain out the window. We have to stop talking about how time feels and start talking about what time actually is. That's not an answer. That's just repeating words. When someone asks what time is, and you say it's the thing that clocks measure, you've said nothing. When someone asks why time seems to flow in one direction, and you say, that's just how it works, you've explained nothing. These are the verbal equivalents of shrugging your shoulders. Real understanding requires going deeper, requires asking operational questions rather than philosophical ones. In physics, being operational means we don't ask, what is the essence of time? Because that's a question for philosophers who enjoy arguing over coffee until the heat death of the universe. We ask, how do we measure it? And the answer is almost disappointingly simple once you strip away the mysticism. Time is a way of ordering events. That's it. It's a labeling system that allows us to say, this happened before that. Imagine you have a deck of cards spread across a table. You can say the jack is before the queen and the king is after the queen. The cards aren't moving. The table isn't flowing anywhere. The order is just a structural property of how the cards are arranged in space. Time is the table, events are the cards. When we say time passes, we're just reading the cards from left to right by convention. This sounds almost too simple to be profound, but it demolishes almost everything you think you know about temporal experience. Isaac Newton believed time was absolute, a giant cosmic clock ticking away in the background of the universe, regardless of what happened within it. He imagined that if you removed all the stars, all the planets, all the atoms, all the light, time would keep ticking. Tick, 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 forever. Measuring nothing, counting nothing, but still somehow existing. Wrong. This Newtonian view dominated physics for over 2 centuries, and it's completely dead. Time is not a background stage on which the drama of the universe unfolds. Time is a measure of change. If absolutely nothing in the universe changes, if no atoms vibrate, no light propagates, no energy shifts from one configuration to another, then time stops. It ceases to have meaning. You cannot define a second without a physical process to mark it. A swinging pendulum completes an oscillation. A vibrating quartz crystal resonates at a specific frequency. A cesium atom transitions between energy states exactly 9 billion, 192 million, 631,000, 770 times. That's our current definition of a second, not some abstract philosophical concept, but a countable physical process. Time is not separate from the stuff in the universe. Time is a property of the stuff. Now you're thinking about this differently. You're starting to see the cracks in your everyday understanding. That uncomfortable feeling, that sense that the ground is shifting beneath your feet, that's your brain rewiring itself. That's what genuine learning feels like. Not the comfortable absorption of facts that fit your existing worldview, but the painful restructuring of your entire conceptual framework. Most people will never experience this because they stop when it gets uncomfortable. They retreat to the river metaphor. But you're still here. What does that tell you about yourself? This is where your intuition fights back with everything it has. You say, okay, but surely time acts on things. Time makes me get older. Time causes the milk to spoil in my refrigerator. Time rusts the car and fades the photographs and turns children into adults. No, it doesn't. This is a linguistic trap that has fooled humanity for millennia. Time is not an agent. Time doesn't have hands. It doesn't reach into your refrigerator and sour your milk. Bacteria do that. Chemical reactions do that. Entropy does that, which we'll get to shortly. Time is just the bookkeeping system we use to track the rate at which those reactions happen. Saying time did it is like saying inches built the house. Inches didn't build anything. Carpenters did. Carpenters with hammers and nails and wood and sweat. Inches just tell you where the walls ended up when the work was done. Time is the ruler, not the worker. Time is the measurement, not the cause. Let's push this ruler analogy further, because this is where things get genuinely weird, where the universe reveals itself to be far stranger than any science fiction writer ever imagined. If time is just a ruler we use to measure the distance between events, what happens if the ruler itself is flexible? What if the ruler stretches and compresses depending on where you are and how fast you're moving? This isn't science fiction. This isn't speculation. This is measurable fact confirmed by over a century of increasingly precise experiments. We used to think a second was a second anywhere in the universe. If you had a clock on Earth and a clock on Mars, they would tick in perfect unison, separated by millions of miles, but synchronized by the absolute nature of time itself. It feels obvious, it feels right, and it's completely false. The rate at which clocks tick depends on where they are in a gravitational field and how fast they're moving through space. This is not a mechanical failure of the clock, not a flaw in the engineering, not measurement error that better technology could eliminate. It is a fundamental feature of reality itself, woven into the fabric of space-time in a way that makes the Newtonian universe look like a child's drawing compared to a photograph. Albert Einstein figured this out in 1905 and 1915 with his theories of special and general relativity, and the physics community has spent the subsequent century confirming every prediction with increasing precision. Think about that for a second. A patent clerk in Switzerland, working alone, deduced the fundamental structure of time and space using nothing but thought experiments and mathematics. Imagine you're driving a car across a giant flat sheet of paper marked with a grid. You can drive north or you can drive east. If you drive purely north, you're making maximum progress in the northward direction. But if you turn the steering wheel and start driving northeast, you're sharing your velocity between two directions. You're moving a bit north and a bit east simultaneously. You aren't going north as fast as you were before because you've diverted some of that motion to the east. The total speed of your car hasn't changed, but you've redistributed it between two perpendicular directions. Now replace north with time and east with space. This is the essence of special relativity, and it will break your conception of reality if you let it. You are always moving through the universe at a constant speed, a speed that happens to equal the speed of light when measured properly. But that motion is shared between space and time, and you get to choose the ratio by controlling your velocity through space. If you sit perfectly still in your chair, reading these words, you're dedicating all your motion to moving through time. You're traveling into the future at maximum speed, 1 second per second. But the moment you stand up and walk across the room, you're diverting some of that motion into space. You're moving through space, which means you must, mathematically must, move slower through time. Your clock slows down. Your aging slows down. Your biological processes tick along at a reduced rate. You aren't breaking the machine. You aren't cheating physics. You're just changing direction on a 4-dimensional map where 3 dimensions are spatial and 1 is temporal. This is why we call it space-time, not space and time, as if they were separate things that happen to coexist. They're aspects of the same underlying reality, directions you can travel in, and your velocity through one affects your velocity through the other. If you could move at the speed of light, which is the maximum speed limit of the universe for any object with mass, you would be using 100% of your motion for space. You would have 0 motion left for time. For a photon of light, time does not pass. A photon is born in the heart of a star and absorbed by your retina in what we measure as 8 minutes later. But from the photon's perspective, if we can speak of such a thing, those two events happen simultaneously. The photon experiences no duration. It exists in a frozen universe where departure and arrival are the same instant. The universe is a static block from the light's point of view, a crystallized 4-dimensional structure with no flow, no change, no becoming. This should break your brain. Let me say that again. For light itself, the thing that lets you see, the thing that carries information across the cosmos, time does not exist. You might be thinking that you don't feel your watch slowing down when you run for the bus. Of course not. You're too slow. You're a biological snail crawling across the surface of space-time at speeds so pathetically small compared to light that the relativistic effects are negligible. At human walking speed, time dilation is real, but unmeasurable without atomic clocks. At airplane speed, it becomes detectable. At satellite speed, it becomes operationally important. GPS satellites orbit Earth at about 14,000 kilometers per hour and experience time differently than we do on the surface. We literally have to program relativistic corrections into their atomic clocks. If we didn't account for the fact that time runs faster in their weaker gravitational field and slower due to their velocity, your GPS would be off by kilometers within a single day. You'd be driving into rivers while your phone insisted you were on the highway. This isn't theoretical physics locked away in academic journals. This is engineering reality that affects your daily life. We're about to connect everything you've learned into a unified picture. But before we do, ask yourself something honestly. Are you actually following this, or are you just reading words and nodding along? Because what comes next requires you to have genuinely internalized what we've covered. It requires you to have actually replaced your intuitive model of time with the relativistic one. If you're still secretly thinking of time as a river that flows at a constant rate everywhere in the universe, the next section will sound like nonsense. But if you've truly updated your understanding, if you've let go of the comfortable story your brain wants to tell, then what follows will snap into focus with crystalline clarity. There's another aspect of time that tricks us, and it comes back to that counting problem, to the idea of pattern recognition. We perceive time as having a direction, an arrow. The past is fixed, crystallized, unchangeable. The future is open, fluid, full of possibility. You can remember breakfast, but you can't remember dinner. You can regret yesterday's mistakes, but you can't regret tomorrow's. Why? If the fundamental equations of physics work equally well forwards and backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play the recording backward, it looks perfectly natural. The planet traces the same elliptical path, obeys the same gravitational laws, appears to be a legitimate physical process. But if you film an egg falling off a counter and shattering on the floor, and then play that recording backward, everyone immediately knows it's fake. The yellow yolk doesn't leap off the tiles, assemble itself into a sphere, seal itself inside a reconstructing shell, and jump back onto the counter. That's not how the universe works. Here's the secret that unifies everything. The arrow of time isn't about time itself. It's about probability. It's about disorder. It's about the mathematical fact that there are vastly more ways for things to be messy than for things to be organized. There are billions of ways for an egg to be broken. The shell could be in 3 pieces or 3,000 pieces. The yolk could be splattered here or splattered there. The albumin could be spread across this tile or that tile. But there's only one specific arrangement where the egg is whole, where every molecule sits in its proper place within the intact shell. So as things move and interact, they naturally stumble from organized states, which have few possible configurations, to disorganized states, which have many possible configurations. We call this entropy, and it's the only reason you feel an arrow of time. You're watching the universe shuffle a deck of cards that started in perfect order. You're a disorder detector. When you distinguish the past from the future, you're really just distinguishing less messy from more messy. Your memories are physical structures in your brain, organized patterns of neural connections that encode information about states of lower entropy. You can remember the egg being whole because that was a more ordered state. You can't remember the egg being broken in the future because memory formation itself is an entropy-increasing process that only works in one temporal direction. If the universe were in a state of maximum entropy, where everything was evenly spread out, where every region of space had the same temperature and density, and nothing interesting was happening anywhere, your brain wouldn't be able to distinguish past from future. There would be no egg to break. There would be no memory to form. In a thermal equilibrium universe, the arrow of time vanishes completely. So now you understand something that most people never grasp. You've spent these minutes fundamentally rewiring how you perceive the most basic aspect of your existence. That's not nothing. That's genuinely rare. Most people will go their entire lives believing time is a river, believing their internal clock reflects something objectively real, believing the past and future have different fundamental natures. But you know better now. The question is whether this knowledge will stick, whether it will actually change how you experience moments, or whether it will fade like everything else you've learned and forgotten. There's a difference between information and transformation, between knowing facts and being changed by understanding. Consider the patterns again. The person who sees the tape measure versus the person who hears the voice counting. They're both struggling to impose a rigid, linear structure on a universe that is actually much more flexible than their evolved brains can comfortably handle. We build these mental models, these counting machines, because we need to survive. We need to know when the tiger is approaching, when the harvest will be ready, when the seasons will change. We evolved to track duration because duration tracking improved reproductive fitness, but we did not evolve to understand the dimension of time as it actually exists. Our brains are efficient survival machines, not accurate reality detectors. We focus on the now because that's where danger lurks and opportunities appear. But in physics, now is a very slippery concept that resists intuitive understanding. If you and I are standing next to each other, our definition of now is effectively identical. The light travel time between us is negligible. Our relative velocities are trivially small, and we can meaningfully say that we share the same present moment. But if you're on a planet a million light years away, and you start walking in a direction that takes you away from me, your definition of now slices through the universe at a different angle than mine does. What you consider to be happening right now, this very instant, as you read this sentence in your reference frame, might be in my future by thousands of years. What I consider right now might be in your past. There is no universal now that blankets the entire cosmos like a single present moment stretching across all of space. The universe is a block of events, a four-dimensional structure sometimes called the block universe. And how you slice that block into past, present, and future depends entirely on how fast you're moving relative to other objects. This is hard to accept. It feels wrong at the deepest level. It feels like I'm telling you that up is down, that left is right, that everything you've experienced directly contradicts what physics reveals. But that's because you're trying to translate the high-level language of relativistic space-time into the low-level language of your evolved biology. You're trying to force quantum mechanics and general relativity through cognitive circuits that develop to track fruit ripening and predator movements on the African savanna. When you try to make the universe fit your intuition, you get confusion, paradoxes, and the persistent feeling that something must be wrong with the physics. But when you let go of what you think time is, when you stop trying to count it like laundry and start understanding it as a dimension, suddenly the equations work and the universe makes sense. This process, this avalanche of discovery, started with Galileo dropping objects to understand motion, continued through Newton's absolute time, shattered with Einstein's relativistic space-time, and continues today as physicists probe the quantum nature of temporal experience. Each generation built on the previous generation's insights, each breakthrough opening doors to new questions that the previous framework couldn't even formulate. That's how science works. That's the avalanche that's been building for 4 centuries, and we're still tumbling forward at accelerating speed, learning things about the universe that would have been literally inconceivable to previous generations. When we try to teach you about the curvature of space-time or the entropic arrow of time, we aren't just giving you new facts to add to your collection. We're asking you to delete your operating system and install a new one. We're asking you to throw away the tape measure in your head and silence the counting voice and replace them with something that corresponds more closely to reality. And that's why it feels so hard. That's why your brain resists. You aren't just learning new information. You're translating against the grain of your own biology, fighting millions of years of evolution that optimized your brain for survival rather than truth. Time isn't a river. It isn't a stage. It isn't a container. It isn't a force that pushes you toward death. Time is a dimension, flexible and relative, woven into the fabric of space-time, marked by entropy's increase, measurable only through change. The fact that we can understand this, that biological creatures on a small planet circling an ordinary star in an unremarkable galaxy can deduce the fundamental structure of temporal reality, that's the beauty of physics. That's what separates genuine understanding from comfortable belief. We don't stop at the river metaphor because it feels nice. We push until we find what's actually true. If you made it here, you're part of something. The community of people who want to understand reality rather than just feel comfortable within it. The people who don't accept easy answers. The people who follow arguments even when they lead to uncomfortable conclusions. This feeling, this sense of having glimpsed something profound, this is what it means to genuinely learn. Not the passive absorption of facts, but the active restructuring of how you perceive existence itself. The avalanche of discovery needs people like you. It always has. It always will. Not comfort, not simplicity. Truth.